Hello everybody, my name is Jeff Jenness. I'm the GIS analyst at the Springs Stewardship Institute, affiliated with the Museum of Northern Arizona in Flagstaff, Arizona. I'm going to be talking about our Springs Geodatabase. Now, Springs Geodatabase is actually a companion to another database, so I just want to give you a quick intro to that. Springs Online is our primary database. It's large, it's very complex, it has lots of data on springs, nearly 1,000 users that are actively working with it, close to 160,000 springs right now, over 20,000 surveys and constant edits going on. So Springs Online is our flagship product. Stores a large amount of potential data about springs and spring ecosystems, and it's really an extremely powerful tool for understanding this fantastically complex and diverse biotic communities and habitats that springs support. It lets you generate a large number of automated summary reports that describe various aspects of springs and the surveys that we conduct on them. It has some simple mapping functionality in that you can define spring coordinates directly on a map and you can visually examine the spatial distribution of springs. Now, this function is most often used when you want to enter data on a new spring. You're just not sure if the spring exists in the database yet. But Springs Online is not a geodatabase. The data is stored in a MySQL Enterprise Relational Database, which is not one of the formats that Esri software supports, so we're unable to use it for spatial functionality. But since we're only storing attribute data in Springs Online, it does mean that users can enter data in multiple datums, which is nice. It makes it easy on the data entry person. It makes the database flexible for users coming from different areas and backgrounds. But of course, it can be tricky to map coordinates correctly when using multiple datums. And so this led us to develop the Geodatabase, which is designed explicitly to work in GIS. Stored in a file geodatabase so it's easy and quick to work with in Esri software. Puts all coordinates into WGS 1984 datum, but it maintains the original lat-long values in the attribute table. And when we apply a geographic transformation to put it into WGS 84, we always record the name of the geographic transformation we used in the attribute table. And since the spring locations are spatial objects now they have a coordinate system, and we currently put all our points into Web Mercator coordinates. And now, this isn't because we have any love of Web Mercator. It's really a bad one for calculating distances and areas, but since most online web maps and web apps are projected into Web Mercator, this makes it easy for us to add the springs locations to an online app if we ever need to. And now we have mappable data. Now that we've imported the data into a geodatabase, and the geodatabase allows us to easily analyze it in GIS, and spring locations are now open to the full range of GIS analytical possibilities. So, for example, we might have some treatment area planned, or maybe there's a fire or some natural disaster, and we want to know what springs are going to be affected or were affected by that event. Maybe we want to put in a road, we want to see what springs are going to be affected by it. These are spatial questions, and so we need a GIS to ask them. So here, for example, we wanted to identify springs that occurred in drainages that were downstream from treatment areas. This is just one example, but this is a pure GIS question, and there's no end to the types of spatial questions like this that you can ask with GIS. And there's no easy way to ask these questions in Springs Online. So just to be clear on the differences between the Geodatabase and Springs Online. First, Springs Online always has the most up-to-date version of the data. As soon as somebody edits it, it's there. It has great reporting functionality. You can make nice reports that summarize various aspects, but it is just not appropriate for GIS. The Geodatabase, on the other hand, the downside is it's a snapshot in time, so that future edits made in Springs Online don't show up in the Geodatabase. Right now, you just need to ask us to export you a new version, and we'll get it to you quickly. It takes about 20 minutes for the code to complete the export, but then you have a snapshot in time. The upside is it is designed for GIS, and so you can do everything that you can normally do in GIS with the Springs now. Okay, so let's take a look at it. Okay, when we provide you with the Springs database, it actually comes with two major components. Each of these comes with lots of little pieces to it. First off, you get a full replica of Springs Online, and this includes the point feature class of the spring locations, plus lots and lots of related tables. It's a complex data set, contains all the source data, but it does take some work to navigate. it has everything, but it is complex to work with. Secondly, we give you a summarized version that answers a lot of common questions that people have about Springs, such as in this example, you want to map by flow. That makes these questions easy to answer because it writes a lot of information right into the feature class itself. It makes it much easier to map these phenomena too. Now let's look at the full replica. This is the main data set. It contains 1-point feature class of spring locations plus 108 related tables. All of these related tables are connected by relationship classes. For example, and with apologies for a complicated slide, everybody loves slides with millions of arrows, right? But it actually does get worse than this, so be forewarned. So anyway, we start with this point feature class of springs, and this point feature class has a one-to-many relationship with a table containing the surveys. This means it can be multiple surveys associated with a single spring. ArcGIS knows how to match them up using the site ID value, which is in both data sets. Then we can also have each site divided into multiple polygons, where each polygon represents a different microhabitat around the spring. And then we can have a single description of solar insolation that the site receives. Solar insolation is based on topography, and that's not going to change over time, so we only have a one-to-one relationship with the solar characteristics. And then the connections just go on and on. Notice all the tables that are linked up to the table surveys table, and there's several more tables connected to Springs feature class. Now this is the structure of the full replica of the geodatabase, at least as of June 2020. And we're regularly adding new tables to both Springs Online and the geodatabase, so this grows over time. But this image is part of the geodatabase download that we provide you. So when you download a geodatabase, this comes to you as a poster. So what can you do with this complex structure? Well, there's two things. First, you can use the Identify tool to dig down through related tables and start getting information. And secondly, you can push selections from one table to another. So I'm going to demonstrate both of those to you. Okay, here's a clip of the geodatabase just restricted to the states of Arizona and New Mexico. You can see all the springs distributed across those two states. They're symbolized according to whether they've been surveyed or not. So I'm going to use the Identify tool to get information on a spring, and this information will be extracted from several layers of related tables. So specifically, I'm going to get a photograph of the spring. The photograph is stored in a table called Table Images, and Table Images is connected back to the Springs feature class going through table surveys. I'm also going to get the flow at a particular spring. What flow do we measure on that day? And that's also in a separate table called Table Flow. That's connected back to table surveys, which is in turn connected back to Table Springs. All right, so let's take a look at a particular spring called High Peak Cienega. I happen to know where it is. I bookmarked it. So we zoom in. Here we are at High Peak Cienega. I'm using the Identify tool. I click on it. Whenever you've used the Identify tool on a feature class, you get all the information in that feature class. So we know all of this information about the spring right there in the feature class. Now we're trying to get information from related tables. So that is, we open a little plus sign here and we see all these tables that are related to the feature class. In particular, we have a table of surveys. We open that up. We see one survey has been done on this feature class back in 2013. Well, I'm curious about a picture and the flow measured. Those are in tables that are related back to the survey table. So flow, here it is, table flow. We open that up. This is the measurements taken at that date. And we can see that on that date we measured a flow of 0.15 liters per second. How about pictures? That's in a table called Table Images. We open that up. We see several photographs have been stored here. These may be photographs. These may also be hand-drawn maps of the area. But I can click on one. This is the information on the table. And notice the lightning bolt, so it's a hyperlink. I click on it, and I quickly see a photograph of that spring site. The photograph, by the way, is stored back on Springs Online, and this is just a hyperlink to it. So that's the Identify tool, letting you dig down through several layers of related tables. Now in this next demonstration, we'll look at how to push selections from one table to a related table. For this demonstration, I'm going to find out what vertebrate species have ever been observed on any survey ever conducted on a spring within 5 miles of the Safford Ranger District in central Arizona. In order to answer this question, I'll need to be familiar with my network of related tables. The vertebrate species are stored in a table called TaxaVert, which is related to a table called Vertebrate Survey, which is then related to the Surveys table, which is then related to the Springs feature class. So I'll need to know this network of connections in order to be able to push the selection of springs through the series of tables to get to the TaxaVert table. Okay, we'll start by doing a spatial selection on the springs that are within 5 miles of this Safford Ranger District. It's a standard select by location function. We're selecting springs near the Safford Ranger District. We'll do a 5-mile search distance, hit apply, and there we go. There are our springs. Okay, now if we open up the attribute table, we see that there are 419 springs within this distance. Now here we're going to use this Related Tables button to push the selection to the Surveys table. We quickly learn that there are 107 surveys that have ever been conducted on these springs. We push it through one more table, the Vertebrate Survey table, and here we see that there are 454 vertebrate species that have ever been observed in any of these surveys. Now we push it one more time to the TaxaVert table, and this tells us there have been 136 unique vertebrate species that have ever been observed on any of these surveys, and this is the list of them here. And that's how you push a selection from one table to another. And now that you have this selection, of course, you can always export it to a CSV file or an Excel file. And you might want to do that if you're going to take it into other software like R for further analysis. We can also push the selection the other way through the network of related tables. These relationship classes let you push selections in either direction. So now I'd like to demonstrate how I can select a particular species out of this TaxaVert table and find out what springs it has ever been observed on. Now I really like Western Tanager, so I'm going to do a selection for that. Here's our record for Western Tanager in our TaxaVert table. I can push this selection to the Vert Survey table, and I quickly see that there have been 60 occasions where a Western Tanager has been recorded on a survey. Now I push this to the Surveys table, and here I see that there are 59 surveys that have ever observed a Western Tanager. So we push the selection one more time to get back to the Springs feature class, and now I see that there are 57 springs that have ever had a Western Tanager observed on them. And I can just use standard GIS functions to zoom to that selection. And here they are, distributed across Arizona and New Mexico. Okay, so that's the full replica of Springs Online. And like I said, that's just one of the 2 components that we provide in the Geodatabase. Full replica has hundreds of characteristics of springs in it, but like we just saw, it's fairly complex and difficult to navigate sometimes. And that's why we created this summarized version, which is the second component that we provide. The summary version is simpler and more lightweight in a number of ways. It still has 1 point feature class, but this time it only has 8 related tables, while the full replica had 108 tables. It only has 3 hierarchical levels of related tables compared to the 6 levels the full replica had. And each spring and survey are summarized by a few common variables that people often are curious about. These variables are written right into the feature class attribute table. We have flow, we have temperature, we have pH, specific conductance, alkalinity, and species richness counts. This is the full map of the related tables in the summarized version. You see it's much simpler than the full replica. The full replica was quite complicated and is getting more complicated every day. But the summary version only has these 3 hierarchical levels and only 8 tables that are related back to the feature class. Okay, let's see what we can do with it. So we're going to start by getting the statistics and an image of another spring, similar to the way we did with the first exercise. Okay, I'm going to go to a site called Western Hospital Flat Unnamed. This is a spring in our database. It's been surveyed. Here it is. All right, so we want to know information that has been recorded at surveys at this spring. Okay, we're going to use our Identify tool to click on the spring like we did before. We see all the information in the attribute table. All this information up here is similar to what we saw before. We do have an image and a sketch map. The sketch means it's a hand-drawn map. We can click on that and we get a quick image. We can also click on the sketch map. Okay. Now what's interesting here though is that we have several new attribute fields, flow attribute fields, specific conductance. These are statistical summaries of all measurements taken during all surveys that have ever been conducted on this spring. So we've had 7 times the flow has been measured, and the mean flow over those times was 0.34 liters per second. Similar statistics for pH, water temperature, alkalinity, vertebrate species count. We also have genus, family, and order count, gives you a sense of species richness. Same with invertebrates and same with plant species. So if we're curious about what plant species have ever been observed at this site, we can scroll down. First we see that 34 species have been observed. Now which ones are they? Well, we open up this, we go to the taxa flora by site, open that up, and these are those species. Nice list of them right here. Now we can also push selection similar to the way we did before. If we select this single spring, we open up the attribute table. Here's our single spring. We can push this selection to the taxaflora table. And it's easy as that. We see all the plant species that have ever been observed there on any survey. Okay, now there's another neat thing you can do with the fact that these statistical attributes are written into the feature class attribute table. It lets us actually map by these attributes. Okay, suppose I want to symbolize our springs by the number of plant species that have ever been observed. So first we're going to zoom back to the full extent of that layer. Open up the layer properties for our summarized feature class. Now I happen to know that if no plant species were observed, that's generally because nobody actually looked. People don't always record all variables when they survey a spring. So I'm just going to restrict my map to just those cases where there actually were flora species observed. Now we're going to go to symbology. I'm going to do graduated symbols. This lets me make larger and larger circles for cases with more plant species there. Go to flora species. We're going to make this a green one because it's plants. And we're going to make a little bit larger circle than just 18 point. Okay, we'll stick with 5 levels. We'll hit OK. And there we go. Easy as that. I can now see where the springs were that had the most plant species observed. So this summary version really does make mapping these phenomena easier and identifying these interesting trends. We've actually used the summary version to find some really interesting trends ourselves. We recently published a paper on springs in the Colorado River Basin. We were looking at several characteristics, and we noticed that hot springs, we define these as all springs with a temperature greater than 30 degrees Celsius. All the springs in a Colorado River Basin that had temperatures of this range were all arranged in this particular band right through central Arizona and southern Nevada and central New Mexico. This band happens to correspond with the tectonic boundary. So this gave real evidence to the fact that tectonic boundaries really are correlated with hot springs. And one last neat feature of the geodatabase is that it comes fully documented and described in the metadata. We spent quite a bit of time making sure that all of our attribute fields and all of our data sets are all described and explained. So when you're curious about any particular code in the attribute table, you can just look up definitions in the metadata. And the geodatabase is also fully described in the documentation that we provide with it. And thanks so much for listening, everybody. If you have any questions, you can reach me at this email address.